I vibe coded a delightfully janky web app. Now we're going to vibe pen test it with Burp AI and see just what it can do. You'll see it figuring out logins, exploring issues identified by Burp Scanner, using context to flag access control violations as false positives, and how the powerful new agentic mode in Repeater can help you craft exploits. All that and more is coming up. This video was made possible thanks to today's sponsor, who is of course PortSwigger. They gave me a bunch of Burp AI credits to use and told me to just play around with the new AI features. This was a super fun video for me to make, and if you want to check out Burp AI yourself, go to portswigger.net/burp/AI. Now, let's jump right in. Okay, so we're in Burp 2025.8.7. Burp AI is enabled. I'm going to browse to this vibe-coded app, the e-commerce site. Discover amazing products with your $10,000 of store credit. Yes, everyone who signs up to this site gets $10,000 of store credit, mostly because I, couldn't implement any other actual payment feature. So it has categories. Right, we can search products. If I search smart, we get the smartphone. We can view details. There's got a login. Maybe I should actually log in to the test user account with the password testpass123. So there's a gallery. I honestly don't remember why I coded this bit, but I think because you can probably tell, hey, maybe there's a vulnerability in this URL. There's a gallery of images. So these are technically all images. They're just very, very basic, right? You can have wish list features. You can view your orders. There's already orders coded into the system. Let's see what Burp AI can do to this website, because there are a few vulnerabilities in this website. What we're going to do first is we're actually going to use the scanning feature along with some features of Burp AI to basically do like a crawl and audit of the site. So we're going to click New Scan here on the dashboard. We're going to click Crawl and Audit. We're not going to use this AI enhancement yet. This is the Broken Access Control False Positive Reduction. Reduces false positives in Broken Access Control scan checks. I'm going to leave that alone for now. We will come back to that though. Going to click Next. We are going to paste in the URL here. Scan using my specified protocols. That's just because the site is only hosted on HTTP. It has no HTTPS. So we're going to click Next. I do have a custom scan called Custom Crawl and Audit Deep. That honestly just makes the scan a little quicker. So it's not going to scan absolutely every parameter. It's not going to scan like cookies, headers, etc. It's mostly going to focus on URL parameters, body parameters, etc. That's just so this isn't taking hours. The first feature of Burp AI we're going to use is the recorded login sequences. Now, this is a feature in Burp Suite Pro, which you can use without Burp AI. So you can technically record this using Burp's browser with the Burp Chrome extension, but we're going to use AI. And so what we're going to do, we're going to select Use Recorded Login Sequence. We're going to click New. We're going to select AI Recorded Login. Automatically generate a recorded login sequence using AI. Click Continue. Let's just call this Test User because that's the user we're going to use. Okay, I guess we just paste in the main URL. I don't think you actually need to paste in the login. I think it will actually try and find a login. Let's see. So Test User and testpass123. There we go. Create a recorded login. So now it's going to use Burp AI to browse to the site. It's probably going to spot that login page, yes, in the top right. And then it's going to use the credentials that we provided. It's going to click the login button. And it's authenticated. You can see test user up there. I'm assuming, yes, there we go. AI recorded login successfully created. We can click OK. We can actually now save this to the library. So maybe we'll do AI test user. Save. Next, this only has 10, so the default resource pool only has 10 concurrent requests. Let's create a new one, AI scan. Let's do a maximum of 100. Probably don't need that, but whatever. Don't need automatic throttling because, this server is fine. Now click scan. Let's see what happens. This is just going to do a basic crawl and audit. So it's going to crawl the application. You can actually see how it's crawling. This is a feature of just Burp Suite Pro in general, by the way, this scan. So we can click live crawl view and see what the crawler is doing. It's basically just going through every single page of the application. It's going to try logging in at some point and seeing if there's anything else to explore there. It's going to try using features of the application. And while that's happening, it's also going to start auditing some stuff, right? So these are all the audit items. If you click the audit items tab, and it looks like it's already found an issue, file path traversal. That was the issue I highlighted might be a problem in that gallery feature. So actually, if we go to the gallery and click view, you can see headphones.jpg is literally a parameter here. So what we can do though is if you click on this issue and go to advisory, we can click explore issue. And this is a Burp AI feature. You can tell all the Burp AI features because they have this little stars, like 3-star sort of emblem thing. If you see that, that means it's a Burp AI issue. I also believe the buttons are all purple. But if we click explore issue, it's going to start another task, exploring file path traversal on localhost. Okay, so basically Burp AI has been sent some context of whatever this issue was, and now it's going to start actually exploring the issue. So confirm path traversal and identify application type. I need to first confirm the path traversal vulnerability works as described and gather more information about the target application. The evidence shows that Etsy password can be accessed via the name parameter in the image's endpoint. I'll reproduce this to understand the response format and confirm the vulnerability is still active. Okay, so one of the cool features is it will show you the request and response that it is showing to make decisions. So it just reran that request and it got the response, which is the Etsy password file. This is basically hosted on Kali, by the way. So the next step, scan for sensitive files and application source. The path traversal vulnerability is confirmed and working. It shows Etsy password with full content, indicating we have read access to system files. Server is using Waitress, and the system appears to be a Debian Kali Linux system. Okay, now that I've confirmed that the path traversal works, I need to escalate the impact by accessing more sensitive files. So it's going to target SSH keys, shadow file, system logs, proc files, common Python application files in the current directory, etc. So, and it's showing you what it's doing here. So it basically sent a bunch of these URL encoded payloads to different files, and you can see some of them got 404s, right? So the Etsy shadow file, it cannot access. This is not running as root. That's good. So it's a bunch of 404s, but then it gets Etsy group, Etsy hosts. Obviously, these are world readable files. They also managed to get the bash RC file from my home directory. So that's interesting. Yeah, so a bunch of stuff here. And you can always click send to intruder as well. And that will send it to intruder. And you can then just replay that. So you will have to, because these are already URL encoded, you do have to deselect URL encode down here. But we can start the attack and basically see the exact same thing. So we can actually view the responses. Let's see the hosts file, right? So there we go. So yeah, lots of interesting stuff here. We can see procnet root there. So yeah, that's kind of a nice feature as well. Go back to Burp AI. What's it doing now? Access application source code serve.py. Great findings. From the intruder attack, I discovered several important files. Proc self command line shows the application is running as Python serve.py. Proc version shows it's Kali Linux 6.12.13. Proc self environ reveals environment variables that might contain sensitive information. Etsy group shows group memberships, blah, blah, blah. Couldn't access Etsy shadow or SSH keys. Since I discovered the application is running as Python serve.py from proc self command line, I should try to access the serve.py file directly. Good idea. This is also everything that I would usually do if I found a file traversal vulnerability, by the way. So it's tried to access it, and it cannot. Interesting. Direct access to serve.py returned a 404, which suggests the application file is not in the same directory as where the images are served from, or there's some path restriction. I need to try different path traversal techniques to locate the serve.py file by going up directories or trying at different common locations. Very good, very sensible. It's going to try various directory traversal techniques like .. etc. to try and access serve.py and other application files. Okay, and you can see again it's doing that here. Did it actually find anything? No. All the attempts to find serve.py and other application files returned 404 errors. This suggests that either the application files are in a location I haven't tried, or there are additional restrictions preventing access to Python files specifically. However, I was able to access system files and logs successfully. Since I couldn't locate serve.py using directory traversal, I'll check proc self CWH's current working directory, which should be a symbolic link to the current working directory of the Python process. Okay, so it did that, and it got a 404 not found because that's the directory access. That makes sense. It says it's unusual. Well, I don't think that's true. It's not unusual that accessing a directory wouldn't return anything because it's not a file. But what's it doing now? Let me try a different approach and look for application-related files in typical locations. Okay, so it's found some of that. It did find the .zsh_history. Excellent find. Let's go to the Kali user ZSH history file, which contains command history. I can see commands related to auto recon. That's fun. This file should contain a complete history of commands run by the Kali user. Cool. Okay, so it found my auto recon usage in here. That's kind of funny. Access Django application files database. Excellent discovery. The ZSH file reveals that the user has been working on a Django application called Vibe e-commerce vulnerable. True. The history shows Django commands like python manage run server, pip install Django, pip install pillow. The application is located in Vibe e-commerce vulnerable directory. This appears to be the webcap application I'm targeting. And it's a vulnerable e-commerce Django application. All correct. That's actually impressive. Now I know this is a Django application. I'll target the most critical files. So the manage.py, settings.py. Okay, so has it actually, oh my God, it's actually done it as well. It's found some stuff. It found the database. Excellent findings. I successfully accessed critical Django application files. Server.py shows this is the main server using Waitress. Manage.py confirms it's a Django application. db.sqlite 3 is accessible and contains the full SQLite database. Yes. Okay, cool. So it actually is, I'm not going to click response because this is the database. It's going to be huge. Successfully downloaded and the complete SQLite database, which contains Django migration data and likely user accounts, products, and other sensitive information. Cool. And it's just, okay, so it's gone even further. So it's trying to access other files like settings file for the secret key. It extracted the secret key. Okay, this has gone crazy. Excellent. I successfully accessed multiple critical Django files, including settings.py, views.py, 43 kilobytes, very large, yeah. URLs.py, admin.py. These files contain the complete source code of the vulnerable e-commerce application, including database models. And this is really impressive, honestly. None of this is stuff that I wouldn't have done myself, but the fact that it just went and did it all by itself is honestly really impressive. And it did manage to, just extract all of this cool information. Super useful. Okay, what we're going to do now is we're going to launch a new scan. I have paused this crawl and audit because it's going to take forever. It is a big application. So now what I want to do is do another crawl and audit, but I want to turn on this broken access control false positive reduction. And what I also want to do is we're going to use the admin account as well. So I'm going to go to the admin panel and put that in as a starting point. I kind of want to start out there. We're going to scan using my specified protocols because, again, HTTP, not HTTPS. We're going to use a custom configuration, and now we're just going to use this back crawl and audit deep. So this is basically a copy of crawl and audit, but I've just enabled the broken access control checks. That's all I care about. I want to see how this false positive reduction thing actually works. We're also going to log in as the admin. We're going to use both the admin and the regular user. So I'm going to use another AI recorded login, and let's call it admin. And I'm going to use admin panel as the URL. And I think this is admin123. Yes. Let's see what that does. So it should browse to the admin page, which then redirects to the login. And now if you do admin and admin123, it will hopefully get to the admin dashboard. There. Okay. So this is a completely separate section of the application. It has recorded that. Let's save that to library as AI admin. Okay, we're going to click next, and AI scan is fine. So let's now scan. And so this is going to do exactly the same thing. So it's going to do that live crawl again, but it's also going to log in as the admin user. And hopefully we'll see this new broken access control system in place. So this AI-powered broken access control, which I believe it will identify potential access control issues, and then it'll use AI to determine the likelihood of them actually being broken access control. Okay, so we have found a broken access control vulnerability. Severity high. The screenshot shows an admin panel with a discounts management section, which includes options to add, edit, and delete discount codes. This type of content is typically part of a back-end interface that requires authentication to access, as it involves managing sensitive business operations and data. If we look at the request, it found that there was an admin panel /discounts page. This is the view it got when it was authenticated. So response 1 is it's authenticated as the admin user. It then reran this with no cookies, so no authentication information at all. and it got the same thing. So it has identified that that's probably not what you want. We can actually confirm that as well. So let's go grab this copy URL, private new incognito window, paste that in there. And yeah, we can just go to admin panel /discounts as an unauthenticated user and just view everything. But if we try and click on something else, we get redirected to the login. So the entire admin panel is not vulnerable. Looks like this discounts area is, though. So that's interesting. And we do have also this false positive broken access control. What it did here, it just went to the root level page of the e-commerce site itself, right? So not the admin panel, but this home area, and it did this authenticated as an admin user, and then it did it unauthenticated. It found that the responses were basically the same, but it is determined that that's not an issue. It has marked this as a false positive, all right? So the screenshot shows a typical e-commerce homepage with a general product listing and categories. It includes a welcome message, product categories, and featured products, all of which are standard for public viewing. There's no personal or sensitive information visible, and the page includes options to log in or register, indicating it is accessible to the public. Yeah, that's also pretty interesting. The fact that it found that and it did mark it correctly as a false positive. That is not an issue. So those are the two examples I think that you can see in this application of how this broken access control works. Okay, so I have authenticated the application as the test user account, and I visited the product page, one of the product pages. So we go back here, this is the request. You can see it's authenticated with my session ID. I can send this to Repeater, click send, we get the response. If you're a new tester, right, and you don't really know, okay, what might this be? Or even if you're like an experienced tester and you see something new that you've just never seen before, maybe it's like a weird header in a request or response, you can, in the Repeater tab at least, highlight this, right-click, and there's this explain this feature. And again, Burp AI features all have this little icon next to them. So if we click that, we go to this explanations tab here. This line appears in the request headers and shows a CSRF token, which serves as a security measure to prevent cross-site request forgery attacks. It's a unique, often unpredictable value that associates the client session with the request, verifying the legitimacy of the request's origin. The server expects this token to validate actions. Okay, so we can also do the same with maybe the session ID, explain this, and any explanations will stay here, right? So in this explanations tab, the text appears to represent a cookie header named session ID. This likely tracks a user's session on the server, enabling stateful interactions. That's pretty cool. Maybe we want to find out more about this waitress server. Maybe you've never experienced waitress as a server before. Let's see what Burp AI says about this. Server header in the response identifies the software handling the HTTP request. In this case, it specifies a waitress, which is a server used for Python web applications. The header can give insights into the server's technology stack. Consider server obfuscation techniques if you're concerned about revealing server details. That's just a quick feature in Repeater now that you can basically just highlight any part of a request or response, right-click, and say, hey, can you just quickly explain this? And you'll get a nice short explanation from Burp AI. Okay, and so earlier I did see that the application, the scan, found a bunch of cross-site scripting attacks, reflected cross-site scripting attacks in the product reviews, the comment parameter. So let's go to product. We have a test user has a comment here. Let's edit it. And see if we can, I'm just going to do a basic HTML injection payload. Okay, so that does indeed work, right? So we can actually see, maybe if I zoom in a little bit, we can see ASDF has been crossed out. But if I try a script alert 1, we don't get a cross-site scripting attack. It looks like it has been stripped, right? So you can see, if we click edit, the script tags are still there in the edited comments, but if we click update, they get stripped out. So what we can do is we can go to Burp Proxy, we can find the request where I sent the script alert, send that to Repeater. I click send and hit follow redirection. We can see, okay, get stripped out. We can actually identify it in the response. Yeah, here we go. So it's stripping out, looks like it's stripping out the word script. script, which is, a technique that has been used in the past for sure to try and avoid cross-site scripting attacks. But what we can now use is this Burp AI agent. By default, if you click this Burp AI agent button, you get the request and response added as context. And what I can say here is I can just basically instruct Burp AI, hey, can you help me out with this cross-site scripting attack? Okay, so I can say, I think the comment parameter is vulnerable to XSS, but it's getting filtered. Please help. And we can click send. And what that's going to do, it's going to say AI task created up here. We can click view task. There's another AI task right here. This is my initial prompt. Check product page for XSS payload. I need to follow the redirect to product 2 to see if the XSS payload is in the comment parameter was executed or filtered. So it's figured out that it does indeed need to follow the redirect. And it's going to do that now. From the product page, I can see that the XSS payload was partially filtered. The original payload was comment script alert 1 script, but what appears on the page is this. This suggests that the application is stripping out the word script from the script tags, but leaving the angle brackets and the content inside. This indicates there's a basic filter in place. Yes. And so it has now used intruder to try another few injections, a few cross-site scripting payloads. The intruder results show all the payloads result in 200 OK responses with different content links suggesting they're all processed successfully. I need to check the product page again to see which XSS payloads have successfully bypassed the filter. From the intruder results, I can see that different payloads produce different response lengths, with some being significantly longer than others. So I think it's trying to figure out which one it's using. It's going to test the image source equals X on error equals alert 1. That's another very popular payload. This approach is more targeted than checking the generic page. It allows me to isolate this behavior on the specific bypass attempt. And it found a successful XSS bypass. So it did indeed figure that, oops, if I click that, this payload worked. I wonder if we go back to the browser and refresh, we do indeed get a cross-site scripting attack. So it did manage to figure out a way around it. And again, this is sort of a thing in Burp Repeater now, this sort of AI agent that sort of helps you and can help figure out bypasses, right? Potential bypasses for various different attacks. In this case, it figured out that script was being stripped from the value, and it figured out some other payloads that worked. Just as a final thing I want to do, going back to the initial file inclusion that we figured, the directory traversal, I fixed the initial injection point in a bad way, right? So we can't get to just etc password now. So it says not found, if we just put that in there. But also, I made it so that even if we do a regular directory traversal, we can't get to it. However, there is a way of bypassing this, and that is by effectively adding a ... before every slash, okay? Because what the fix is, it will just strip out one instance of a ... wherever it sees it, but it won't go through and do it again. So the upshot of this is once all these ... are removed here, it actually creates new ... which then get to the etc password file. What I want to see is, can the agentic partner, can Burp AI in Repeater figure out this bypass? And so what we're going to do, we're just going to send it just the regular request here. So I'm going to go to Repeater, and I'm going to actually start off with a ... because this should technically return the same file, right? I think the name parameter is vulnerable to directory traversal, but it seems to be filtering out some common payloads. Can you bypass this? Let's see how it does. So it's created a new AI task, and it's going to try and figure out how to get around my bad mitigation. Based on the user's instructions, the name parameter is vulnerable to directory traversal, but seems to filter common payloads. I need to test various bypass techniques. The current request shows /headphones.jpg works normally, so I'll test multiple encoding variants, double encoding, Unicode bypasses, and path manipulation techniques to see if any can bypass the filtering and access sensitive files like etc password. Okay. It's found it. All right. We got a bunch of 404s, and the last one, look, ... // confirm directory Successful directory traversal bypass. The intruder attack showed that most directory traversal payloads returned 404 errors, but one specific payload, this one, returned a 200 status code. Truncated response shows returning what appears to be the etc password of file contents. And so, yeah, it definitely found a bypass. This isn't actually the same bypass that I thought it was going to find. So well done there. It found another bypass, actually a far simpler one. The etc password file was successfully retrieved. They confirmed that, and then it's gone off, and it's done even more. So it's tried to basically use this technique to access a bunch of other files, and it has indeed found some more. So not only did it do what I asked, which is, hey, can you bypass this? It's like, okay, well, now I found a bypass, it's going to try and grab some more file content. So that's really useful and interesting. And it looks like it did try and examine the Nginx config. This obviously isn't using Nginx, so that would not work. But that's pretty cool that it at least found the directory traversal bypass, and in fact a more efficient one than the one I was thinking of. So yeah, interesting. I like it. That was Burp AI. I'm genuinely impressed by the Explore Issue feature and the new Agentic mode in Repeater. I feel like those can help pen testers of any skill level, especially if you're having trouble with some kind of bypass. Thanks again to PortSwigger for sponsoring this video. And if you want more information, you can check out Burp AI by going to portswigger.net/burp/AI. If you enjoyed this video, please give it a like, subscribe to the channel for more cybersecurity content, and of course, leave a comment. I want to make some more videos using Burp AI, maybe exploring something more complex or some of the AI-powered extensions that people have been making. If that's something you want, let me know. Until next time, happy hacking.